Good day to you children. Previously, we have studied about polynomials and their various types. We have learned that this x plus 1 is a polynomial with degree 1. Here degree means the power of the highest power of the expression. Here the highest power of x is 1. So this is a polynomial with degree 1. We also call it as a linear polynomial. Linear polynomial. Next we have the polynomials with degree 2. So here is an example, x square minus 4, where the power of x is 2. So this is known as a quadratic polynomial. Quadratic polynomial. And next we have the polynomials with degree 3, x cube minus x square plus x plus 2. This is one of the examples for cubic polynomial where the highest power of the variables is 3. So this is a polynomial with degree 3 and it is called as a cubic polynomial. And when we equate these polynomials to 0, say for example, x plus 1 is equal to 0 or x square minus 4 is equal to 0 or x cube minus x square plus x plus 2 is equal to 0, we get what we call as equations. And when these quadratic polynomials are equated to 0, that is x square minus 4 is equal to 0. This kind of equation is called as a quadratic equation. And these equations are the topic of our discussion in this chapter named as quadratic equations. Quadratic because the highest power of the variables in these equations is 2. We'll be learning about the quadratic equations, how to form them in our from our day-to-day life situations, and how to find their solutions. Solutions means finding the value of x which satisfies the equation. The general form of quadratic equations is of the form ax square plus bx plus c is equal to 0. This is the general form of the quadratic equations, where a, b and c are real numbers with a not equal to 0. If a becomes 0, then this first term, that is the term containing the highest power, will be reduced to 0. Then we will have what we call as a linear equation. That is the highest power will become 1 in that case. That is why we say a is not equal to 0. So a, b and c are real numbers and a is not equal to 0. So ax square plus bx plus c is equal to 0 is the general form of quadratic equations. Let us now directly go to solved example 2 of your textbook. That is, the question is to check whether the given expressions, the given algebraic expression form the quadratic equations or no. This is example 2 from your textbook. Solved example 1 we'll visit later. So the first expression is x minus 2 whole square plus 1 is equal to 2x minus 3. We have to check whether this expression forms the quadratic equations or no. So here first let us expand the x minus 2 whole square on the left hand side. Using the identity a minus b whole square, we get x square minus 4x plus 4 plus 1 is equal to 2x minus 3. Now transposing the values on the right hand side to the left hand side, we get x square minus 4x, 4 plus 1, 5, plus 5 plus 2x will become minus 2x and minus 3 will become plus 3. And on the right hand side, what is remaining is 0. So this implies x square minus 4x minus 2x is minus 6x Plus 5 plus 3 is plus 8 is equal to 0. Therefore, the expression is or forms a quadratic equation. Is a quadratic equation because it is of the form ax square plus bx plus c is equal to 0. Here a is 1 x square, b is minus 6 x plus c is equal to 0. So this expression or this equation is a quadratic equation. Now moving on to the second equation, that is x into x plus 1 plus 8 is equal to x plus 2 into x minus 2. So simplifying, opening the brackets and simplifying, we get here x into x square plus x plus 8 is equal to x plus 2 into x minus 2 is a plus b into, is of the form a plus b into a minus b. So it is x square minus 4. Now transposing, x square plus x plus 8 minus x square plus 4 is equal to 0. X square minus x square cancels each other. What is remaining is x plus 12 is equal to 0. Is not a quadratic equation because it is not a quadratic equation because here you can see that the highest power of the x is 1. It is a linear equation, not a quadratic equation. So this is the solution. Moving ahead to the third equation, we have third equation, x into 2x plus 3 is equal to x square plus 1. So opening the brackets on the left hand side, we get 2x square plus 3x is equal to x square plus 1. So now transposing, we get 2x square plus 3x plus x square will become minus x square minus 1 is equal to 0. So 2x square minus x square is x square plus 3x minus 1 is equal to 0. So this is of the form ax square plus bx plus c. Therefore, it is a quadratic equation. And the last equation given to you in the example is fourth one, x plus 2 whole cube is equal to x cube minus 4. We know that a plus b whole cube can be opened as a cube plus b cube plus 3a square b, that is 3 times x square into 2 plus 3ab square, that is 3 into 4 into x is equal to x cube minus 4. So this can be rewritten as x cube plus 8 plus 3 2s are 6x square plus 3 4s are 12x is equal to x cube minus 4. Transposing RHS to the left hand side, we get x cube plus 6x square plus 12x plus 8 minus x cube plus 4 is equal to 0. Here x cube minus x cube cancels each other. So what is remaining is 6x square plus 12x plus 4 is equal to 0. So it is of the form ax square plus bx plus c is equal to 0. Therefore, it is a quadratic equation. So this is the required solution for your Solved example 2 from your textbook. So in exercise 4.1, I am leaving the first main to you as your homework because the question is to check whether the following given equations are quadratic equations. There are 8 questions. Since we solved 4 examples on the same before, I hope that you can solve them on your own. So I will directly go to the second question, that is represent the following situations in the form of a quadratic equations. So in the first question of second main, the question says the area of a rectangular plot is 528 meters square. So area is equal to 528 meters square. This is given. The length of the plot in meters, the length and breadth both are in meters, the dimensions are in meters. So the length of the plot is 1 more than twice its breadth. So if breadth is, let L be the length, and B be the breadth. So now if the length of the plot, that is L, is 1 more than, when they say 1 more, that means plus 1, okay, 1 more than twice its breadth. Twice its breadth means 2 times its breadth. Then find the length and breadth. The question is not to find the length and breadth, but represent this situation as a form of quadratic equation. So from given, we know that length is 1 more than twice its breadth. So L is equal to 1 plus 2b. Now we know that area is equal to length into breadth. So the value of area A is 528 meters square, which is equal to, we can rewrite length in terms of breadth as 1 plus 2b or 2b plus 1. So length is 2b plus 1 and breadth is b. So 528, this implies 528 is equal to 2b into b, 2b square plus 1 into b, b. So this implies transposing it to the RHS we get, or transposing everything to LHS and rewriting, we get 2b square plus b minus 528 is equal to 0. This is the required quadratic equation from the given situation. In the second question of second main, the product of two consecutive positive integers is 306. We need to find the integers. So two consecutive integers, that means the numbers which come one after another, like 2, 3, 4, 5, 6, 7, like that. So if one integer is x, then since it is the consecutive integer, then the other integer is x plus 1. I said consecutive numbers are neighboring numbers like 2, 3. If one number is 2, then the consecutive number is 3, next consecutive number. And if the next one consecutive number is 6, then the next consecutive number is 7 plus 1. So if one integer is x, then the other integer is x plus 1. They have told us that the product of these integers is 306. So x into x plus 1 is equal to 306. So this implies x into x square plus x is equal to 306. So this implies on transposing we get x square plus x minus 306 is equal to 0. This is the required equation for the given situation. Third question from the second main is an age-based problem. So the question is, Rohan's mother is 26 years older than him. The product of their ages 3 years from now will be 360. we would like to find Rohan's present age. So first, we need to find Rohan's present age, no? So let Rohan's present age be x. Let Rohan's present age be x. Then his mother's present age will be, they have told us that his mother is 26 years older than him. So if his age is x, then his mother's present age is x plus 26. So let us now represent the situation as present and 3 years later into the future, because that will make the things easier in a table. So Rohan and his mother, Rohan's age, this is present, this is after 3 years, because the question says their product of ages after 3 years. So Rohan's present age is x. Then after 3 years, his age will be x plus 3. His mother's age is x plus 26, present age, because she is 26 years older than him. Then after 3 years, her age will be x plus 26 plus 3, which is nothing but x plus 29. So we got our two variables, factors needed to find their ages. Now they have told us that the product, that is x plus 3 into x plus 29, is equal to 360. They have told us that the product of their ages after 3 years is 360. So from multiplying them and simplifying, we get x into x, x square, x into 29 plus 29x, plus 3 into x, 3x, plus 3 into 29, 9 3s are 27, 7 2 carry 3 2s are 6, 287. So 87 is equal to 360. So this implies x square, 29x plus 3x is plus 32x. So 360 minus 87, we get 360 minus 87, we get 332. 273 minus 273 is equal to 0. So this is the required quadratic equation. If we solve this equation, then we find the value of x, and that value of x will be Rohan's present age. So now, lastly, in the fourth question of the second main, we have in the fourth question, they have given us a train travels a distance of 480 kilometers at a uniform speed. If the speed had been 8 km per hour less, then it would have taken 3 hours more to cover the same distance. We need to find the speed of the train. So since we need to find the speed, let the speed be x. The speed be x. So there are two. They have told us that a train, the distance traveled by this train, the distance is equal to 480 kilometers. And if speed was 8 km per hour less, that is, if speed was x minus 8, if the speed was 8 km per hour less, then it would have taken 3 hours more. So when the speed was x, the distance traveled is 480 kilometers in certain time. So that time t is equal to distance upon speed. So which is equal to 480 kilometers by x. Similarly, the time would have been 3 hours more. to cover the same distance if the speed was 8 km per hour less, then the time taken would be t plus 3 hours more. So which will be equal to cover the same distance 480 kilometers by x minus 8. So now subtracting both these equations, equations 1 and equation 2, we get t plus 3 minus t is equal to 480 by x minus 8 minus 480 by x. So t minus t cancels each other. What we have left is 3 is equal to 480 by x minus 8 minus 480 by x. Since the denominators are different, to subtract we need to take their LCM. Since both of them are different, we will directly multiply them. So 3 is equal to, here the denominator will be x into x minus 8, multiplying both of them after taking LCM. X minus 8, what is left? Into x, and here x, so what is left is x minus 8. So multiplying them, 480 into x minus 480 into x minus 8. So 3 is equal to, taking 480 common, 480 outside, so x minus, we have x minus 8 into the brackets, divided by x into x minus 8. We can transpose the denominator to the left hand side. We'll get 3 into x minus 8 is equal to 480 into x minus x minus x minus minus into minus plus 8. So x cancels each other. What we have is 8. And on the left hand side, 3 into x square, 3 into x square minus 3 into 8, 24x is equal to 480 into 8. So this implies 3x square minus 24x is equal to 8 zeros are 0, 8 8s are 64, carry 6, 8 4s are 32, 32 into 6 is 32 plus 6 is 38. So on transposing, we get 3x square minus 24x minus 3840 is equal to 0 is our required quadratic equation for the given situation. And this equation can be further simplified by dividing the whole thing by 3. Divide by 3, we get x square, 3 cancels out, minus 3 8s are 24, so minus 8x, and whereas 3840 minus 3 1s are 3 2s are 3 8s are 0s are is equal to 0. So this is the reduced form of the quadratic equation, which has been more simplified. So this completes your exercise 4.1.